Good afternoon. I would like to talk about SOUL's the Ruby Serverless Application Framework from ELSOUL. Nice to meet you. My name is Fumitake Kawasaki. And let me briefly introduce myself. I was born in 1985 in Kanagawa Prefecture, and I currently live in Amsterdam, the Netherlands. After graduating from Yokohama City University in 2011, I joined Rakuten Inc. and founded ELSOUL Inc. in 2012 to contribute to the digitalization of Japan. In Japan, I was involved in web advertising, website development, business systems, and web application development. After establishing software development companies in China, India, and Vietnam to develop fast application, I moved to USA and Europe to conduct research on efficient application development. The Ruby serverless framework SOULS was developed to solve problems in the field based on my experience in software and business from sales to R&D. It was certified as an advanced R&D project by the Dutch government. Now we are releasing SOULS as an open source framework and hope to contribute to the solution of digital transformation scenarios and overall software development issues in all industries. Now, here's today's agenda. First of all, I'd like to talk about some of the issues in the software development, operation, and maintenance, and briefly explain the purpose of the SOULS project and its architecture. After that, I'd like to give a live coding demonstration. First of all, I'd like to briefly review some of the issues in today's software development, operation, and maintenance, such as server management and high cost of code changes and bugs, which I'm sure you are all painfully aware of. Well, historically, server administration has always been a painstaking task for us and has given us many sleepless nights. While each server configuration is quite important, it is very difficult to visualize efficiently and to grasp the whole picture. The differences between the development environment and the production environment are not uncommon, and it takes time to identify server errors even if there is only one typo. In many cases, server resources are prepared in advance, so it is necessary to predict the peak access load to the service. If the prediction is wrong, the server will either go down or there will be a significant response delay. So many problems arise around server administration that the time and effort spent on them can be quite significant. The software industry as a whole has not placed a high value on code maintainability, and as a result, far more money and effort is spent on software maintenance than was initially spent on development. If the software is being used, changes are inevitable, and someone will actually change the code. Adding features is one of the most common requests, but until recently, the industry did not have a way to properly add features. And this is because the team that maintains the code is often not the team that originally developed the code. And if the original developer is the one who asked for the enhancement, it is difficult to remember why it was designed the way it is. In many cases, developers spend more time reading the code than writing. Therefore, if the change is large, they will try to rewrite the part rather than taking the time to read and understand the current code. The current situation is that many teams do not understand the current design, but rather try to add functionality on their own. As a result, the overall quality of the system degrades, and it becomes more difficult to extend the system. More software is not designed to handle enhancements well, and adding features requires redesign, which is risky and expensive. The tangled nature of software makes it difficult to add features without a domino effect. It is not uncommon for a new feature to spawn a new bug, which in turn spawns another bug, and when this is fixed, that will continue. So that is a vicious cycle that we often see. Most of the reasons why software development project fails are due to bugs. The cost of fixing bugs is high. It increases development cost exponentially, stopping the project and ruining the software. In fact, I don't think many software developers spend a lot of time fixing bugs. The bug might be a small one, but finding the bug itself is difficult. because finding them itself is very difficult. As of 2013, Mac OS X contained about 85 million lines of source code which can be crashed by a single typo. A bug can be as small as a typo that the compiler can find, or as large as a flaw in the overall design of the system. Bugs are just the tip of the iceberg, and fixing one can lead to multiple other bugs. The structured software is so intertwined that fixing a single bug can be like playing whack-a-mole. What you thought would be a quick fix in a few minutes can turn out to be a wave of changes that reach the entire system. So far, I have talked about the pain points of the software, but we want to break through this situation. So we have launched the SOULS project, which aims to lower the cost of software development, operation, and maintenance. There are 3 points that we are particularly conscious in our design. The first one is to automate duplication of work. I'll never forget how impressed I was when I first got my hands on Ruby Rails. We wanted to realize the same development environment, even the cloud-native environment, so we used Active Record, and we constructed a schema stacker for the distributed system. Because of the legacy Rails, we also value conventions over configuration. So it allows you to develop a new project with zero config and complete the templates process without missing the configuration file. With the support of SOULS CLA, developers no longer need to edit configuration files directly. SOULS scaffold automatically generates crowd based on the information in the active record schema. And the type definition files and test files are generated at the same time so that developers can start thinking about the business logic. That's where the Ruby's true potential will be demonstrated. In addition, we have automated the tedious routing process, including the connection and deployment of pub/sub, which is likely to increase human resources. Oftentimes, developers will find himself doing the same thing again and again. We want to rescue him from that. Secondly, we want to stabilize code base. Since Ruby 3.0 static type check-in by RBS available, this combined with the ID support by Steve will allow us to find bugs while coding at the same time and prevent them from getting into the code base. It makes building large applications safer and keeps your team agility higher. Using Robocop as a linter formatter unifies the coding style of the team and brings order and transparency to the code base. This helps ensure consistency in development, reduces the burden of operations and maintenance. The tests provide immediate feedback so that changes can be detected immediately if they affect other parts of the system. Unit tests can be drawn up with RSpec and can verify code independently and prevent bugs from entering the system. And thirdly, infrastructure stability, using GitHub Actions to minimize problems caused by code integration by deploying small pieces of code before committing. If test fails, the error is not carried over to the production environment, so you can check the results and make correction calmly. Docker allows you to create the same environment anywhere by sharing infrastructure files, so you can continue development on reproducible infrastructure without having to worry about the differences between your local development environment and the production environment in the cloud. Applications are deployed in the Google Cloud, allowing you to scale globally based on traffic, ensure reliability, safety, and security, and provide real-time log management. So no need to do the cold stars and always ready to get the request, and also possible to deal with the fixed IP. So that's why we designed the SOULS architecture. So this is the overall view of the architecture. It is a scalable system, just like making the Rails development. That's the SOULS. And once you have made, it is stable. So together with the business, it can grow. Seeing is believing. So I would like to make the live coding of the SOULS tutorials. So let me actually make the live. All the necessary packages are already installed. So we will start by creating an application with a quick start, SOULS new. So we will make the source application. We will make this application with the name RubyWorld 2021 and create a sample block GraphQL API and mail worker. Now the template is downloaded. Now let's follow the documentation. First, go to the API directory. Then start post GRSUQL using the source docker command. Next, create the database. Then we will migrate the database. Now use the source code S command to start the source application. Access localhost 4000. If you see API running, you are all set. You can use the source help command to check the list of source CLI commands. Some of the most frequently used commands are here. The source check command performs a type of check using RBST. The source test command executes robocall formatting and RSpec tests in order. The source test all command executes the source check command and the source test command in sequence. The source upgrade gemfile command updates the gemfile and gemfile.log versions to the latest versions. The colors changes for patches, minors, and majors. If you want to fix some specific gem version, you can edit the config fix gems array in config/source.rb to be removed from the auto updates list. Now let's deploy the API. First, create a GitHub repository, make your first commit, and push it. And similarly, create a Google Cloud Platform project and run the source upgrade config command. You can interactively set the GCP project ID, region, and application endpoint. The settings will then be reflected in mothers and API, respectively. Execute the source gcloud IAM setup key command. First, a Google login screen will pop up. So sign in with a Google account associated with your GCP account. Sign with a Google account associated with your GCP account. Create a GCP service account and grant the necessary permission to deploy, and you'll be registered in the GitHub secret. You can review the list of source gcloud commands in source gcloud help command. Create a cloud SQL with a source gcloud SQL create instance command. Set the passwords interactively. It may take a few minutes to actually create it. When the creation is finished, the SQL configuration will be output to .env.production and to the API.env. Use the source gh secret set command to register the environment setting defined in .env production to the GitHub secret. To access Cloud SQL, add your current Internet Global IP to the Cloud SQL whitelist. Go to the API directory and run the source db command with the E option. Verify that the test passes with the source test command before deploying. Go to the mother directory and rename the GitHub folder to GitHub to reflect the workflow of GitHub. If you push, now change the name to GitHub Actions. And if you push to the main branch, automatically the deploy will start. The source gh command, we would show the GitHub Actions. If the workflow is successful, it has been successfully deployed to Google Cloud Run. Now, I will move to the topic of making the models. In Soul's uses active record, we can manipulate the model in the same way we are familiar with in Rails. In this section, we will create the model we need for the blog. We will create a migration file, use a source DB create migration command. First, we will create the user table. In addition to the migration file, the model, RSpec, and RBS files will be generated automatically. We will copy the contents of documents and define the columns.
SoulDB help command is used to confirm the list of the SoulDB commands. And then execute the SoulDB migrate command. Then the user table is produced. By adding help option to source command, you can confirm the details of the command. Likewise, article category, article comment table is produced, which are necessary for the blog API that we are producing this time. Migration file, likewise the user table, the contents of the document is copied and produced. And execute the SoulDB migrate command. Now table is done. Next, the definition of the model, likewise cited from the documents. When the user model is updated, the file is indicated red, which means there's a generation of the type error. Therefore, in the SIG folder, update the user.rbs file, which is defined in the SIG folder, and then the type error disappears. Now I'd like to go to the scaffold command execution, the topic for the execution. So G scaffold command can be executed every table, but I will do it all of the scaffold for all of the tables using the scaffold or command. The Cloud API, the file is automatically generated, and then go into the definition of the test data in factory bot. And then if you have the data very close to the actual data, the later it will be easier. And then cite the document content and renew the factory and the source framework for the test data. Faker, factory bot, and Gmail is adapted. Thank you for the developers, and particularly the user table used in Japan. Gmail is very convenient. Thank you. And execute the test and confirm there is no abnormality. In the first test, the Robocop is produce automatically the file, and this is formatted, and the sources application is started, and the GraphQL API will be viewed. The API is data is indicated in the front end, and this is a repository which is made public, and please use it freely. Registration and indication and the renewal and the logical deletion and the physical deletion are done. with the GraphQL query, response is returned responding to the relay. This is the illustration, indication, and update and logical deletion, physical deletion in that order. And this is the data registered. Data is registered, and then registered data is indicated and displayed. GraphQL playground is in the middle of that entry. Suggestion is indicated. Registered data is updated, and then the data registered is logically deleted. Is deleted, flag is true. And after the logical deletion, if you display it once again, there is the data remaining there. And this is physically deleted. After the physical deletion, the data is disappeared. And also from the display, GraphQL playground generates a document automatically. Therefore, scheme and the query information can be seen on the right-hand side of tab article. UI, there's no data, but GraphQL playground can produce the data and then reflected in UI. And then process data is changed from UI. Now modified and confirmed with the GraphQL API. The data is corresponding to that modification. And then the article is a producer from UI. Now, confirming from the playground, data is corresponding. So, source framework can construct the GraphQL API at high speed, and the next N1 query under question is evaded. And source framework Shopify GraphQL batch loader is adopted. I would like to thank the developers and team of the developer. Thank you very much. I would like to produce a test data first. CRB, the initial data is defined there, and citing the document content, and I will go forward. Now, db seed command is executed. Now, test data is produced. User type is connected with the article edge, and then from the list of the users, the article connected to user can be obtained simultaneously. Let us do it from the document. And then GraphQL playground, I would display this. Therefore, article related to the user is obtained from the user query, but going back to the console, the by user article query is issued, as you see. Therefore, for the user type, batch loader is implemented. Now, citing from the document, once again, there is a type error. For that, we need to update the RBS file. And then, once again, execute from the GraphQL playground. The same result, but going back to the console, query is optimized. Now moving on to the additional topic of source worker. In the worker, job query is used. For the editing of the model, we need to go to the API directory. Now, let us go to the source create worker, command to create worker. And then worker is created in the apps directory, and in the SIG directory worker is added. This is the worker named mailer, and going to the worker directory. So sync model command is executed first, and then db model factory related files are copied from API, and then solg job command is executed to produce mailer. Therefore, we add the mail option, and the template file is produced for mailgun. RBS RSpec templates are generated automatically. Now mailgun issues in the key and added to the environmental variables, and now added the associate add command is executed. This is a dialog and the key value are set. After adding the key to the environmental variable and after the setting, GitHub's secret would reflect this automatically. Likewise, mailgun domain is set. The value is added dialog, and after the setting automatically added, and the contents of the template will be updated in each address, and start the worker with a Serverless command, and localhost 3000 is accessed, and worker learning is indicated. Now playground query is sent and execute the job. When it is executed, job done is returned, mail is delivered. In the case of the execution locally, mailgun console, the development environment global IP should be added to the whitelist. Now mail trigger is implemented in the API, and if there should be some new comment in the blog article, the mail will be delivered. This is a notification by mail. The create comment would have a trigger, and after the comment is made, the trigger is embedded. In the case of a production, Google Cloud Pub service execute. In the case of development environment, from the API to worker, post is sent. Now article is connected with the comment edge. You see type error like in the previous case. You need to update RBS file. So S all option and API and worker are started, and the comment is generated from API. Then the job is executed from the worker, and then from API to worker, the transmitted, and the job is executed. New comment mailer.rb so that it will be possible to receive more than one, and argument is added, resolve method, and as is taken, and for the notification of the specific article ID is put in the message, and the trigger of API is updated, and then from the playground the comment is produced once again. As you see, job done. Going back to console, you see that display on the console. Therefore, the ID of the article is sent by mail. Now, deploy is completed just pushing the main branch, like in the case of API. It takes about 5 minutes to deploy. After the completion of deploy, Serverless command is executed. By that, source.rb endpoint is updated. After this update of the endpoint, so sync pub sub command is executed. This is automatization of the pub sub endpoint setting and routine setting, and the job implemented on the worker is automatically Google Cloud pub sub and generated. I talked about the source framework and API worker and deployment. That's all for my presentation, but there are many more and the functions and the commands that I didn't introduce today in my presentation. If you are interested, please look at the document. Thank you very much.